this. Okay, so we want to put this into argument form like the above, where you have a premise, and then a conclusion. So let's just look at the first sentence. If we raise the minimum wage, costs will go up. So this would be our P. This would be our Q, correct? So we could first write this up as P then Q. That's our first premise. And then it says, if costs go up, the economy will not improve. So that would be Q, then negative R, right? If we raise the minimum wage in the Twin Cities, then the economy will improve. Okay, so that would be P, then R. Wait, P, then R. Okay, yep. Okay, and then the last statement is, therefore the economy will improve anyway. So that would be therefore R. So I want to make a compound statement with this in the form that I have up here. So it's going to be a bracket, and I'm going to put all my premises inside. So it'll be P then R, or Q, and Q then not R, and P then R. Yep, you put all the premises inside. Therefore R. So from here, we're going to make our truth table. So we have 3 variables. So that means we need 8 rows on this. 3 would be true. Well, you're starting off with true, 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 true. False, 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 false.
Because this has an R.
Yeah, it has an R. So then we go true, true, false, false. And then it's true, false, true, false. Then you would take, it would be 8 trues, 8 falses, then 4 Qs, 4 trues, 4 falses, 4 trues, 4 falses. I mean 2 and 2, 2 and 2, and then 1, 1, 1, 1, 1.
Do we have to make one that's this long?
I'm pretty sure there's at least one PQR in there. Okay?
Oh, boo.
All right. All right, so there won't be one with this many premises in it. I picked a hard one because if you can do this, you can do the ones on the test. Okay? Then you might need to study more. Okay, so what's the first column I'm going to write here?
P then Q.
P then Q. Okay, so what are we looking for if we're doing an if-then statement?
True then false.
True then false. Well, these 2 are true, but then we got 2 falses right here, and then the rest are true. All right? What am I going to do next?
The next one.
Q not R. Let's do a not R first. So it'll be false, true, false, true. And then we'll do Q not R. So we're looking at these 2 columns right here. And we have to have a true and then a false to make it a false. Well, we already got one right off the bat. This one's true. This one's true. Then we got another one right here. And I think the rest are true. Okay? Now we want to do what? P then R. Good. So looking at, oops. I know.
No, stop.
Okay, P then R, we're going to see this will be a true,
It's false.
false,
True, false. False.
and then the rest are going to be, nope, they'll all be trues.
True.
Okay. Now what are we going to do?
The whole shebang. Well, you could do P, then Q, and then Q, not R.
Or you could just do the whole.
Let's do these two right here, okay? First. So it's going to be P then Q, and Q then not R.
You know exactly what Joey said.
Yep. Okay. That is exactly what Joey just said.
False, true, false, false, false.
Okay, so we're looking at this one right here, and we're looking at this one right here, and we need two trues to make it a true, right?
False,
So-
true, false, false, false.
Okay, then we can add this part to it right here.
You should just.
Okay, so this will be an and P then R. So this is a false because we're looking at,
So when you put that one first, one on the right first.
yep, this one, and then we're looking at this one, right?
So the one on the. Never mind.
So these both have to be trues.
No, so which one comes first? Like,
On this one, it doesn't really matter because it's an and statement.
Alright, just like.
Okay, so direction doesn't matter. As long as they're both trues, it's a true. This is their first two are false. This one's a false. This one's a false. This one's a false, and then the rest are true. Right? Okay, now we can put it all together. We have an if-then statement here. Right here, and this is all going to go in this one right there, okay? So we need to have this go first, this goes second. So the first one, if it's a false to start with, you know it's going to be a true, because false then true doesn't, or false then false is always a true. But the bottom statements, here we are, we have a true and then a false. So that's a false. And then a true is a true. And then a true and then a false is a false.
So false at the bottom.
Yep. So notice that, yeah. Notice that there's two falses here. What does that make this argument? Is it valid or invalid? It is invalid. It has to all be true in order to be valid. So on the radio, after hearing this morning, we can show that whatever they were saying there about the economy raising because of this, it makes it an invalid argument. The economy might improve, but it would have nothing to do with what their argument was about. Okay? So that's why you have to be very careful when you're watching or listening to some of these arguments. Think it through before you go vote. Okay. Whoops.
Okay.
Yeah.
In order to be valid, does it have to be tautology?
Yes, it has to be a tautology. Okay? All right, let's look at the next one. This one says determine a valid or invalid argument based on the, you know that half sheet of paper I gave you guys? That looks like this for the projects. Okay, this one is on the test. It's actually reprinted on the test, okay? So you'll be using this to determine if it's a valid statement or not. So let's write this out. We have, if a parrot talks, it is intelligent. This parrot is intelligent, therefore this parrot talks. All right, so what would be my P? What would be the P in this case? So if a parrot talks is the first part. Q, parrot is intelligent. Actually, you could say parrot. Here, I put it. Okay, So the argument is this, P then Q, it's an if-then statement. It says the parrot is intelligent, so that would be a Q, therefore P. Do you guys remember what that was called from that half sheet of paper that I gave you guys? There were 4 valid and 4 invalid. This one is called the fallacy of the converse. So on your test, if you have this, there's a section on here that uses this table. What you need to do is, first of all, be able to write it in symbolic form, and then show that it's, you know, if it matches one of them, you'd write the title of it, fallacy of the converse, on there. Okay, so it's invalid. It's on the test. I mean, this table is on there. Okay. The other class had to memorize it.
Thank you. You want that?
All right, so let's go to the last one. This is an Euler diagram, and it says to determine, we have to use the Euler diagram to determine if it's valid or not. So it says all mammals are warm-blooded. So if I have mammals, I'm going to put that inside a circle that's warm-blooded. And then it says all dogs are warm-blooded. So I need to make another circle for dogs. Now, where do I put that circle?
You can put it inside warm-blooded or inside mammal.
Yep, I could put it right here. I could put it right here. I could also put it like this. It would be anywhere inside that warm-blooded circle. Okay? So it says, therefore, all dogs are mammal. Well, that's only true if that circle's inside the mammal. But there's 2 other possibilities where it's not. So this is an invalid statement.